So for day 3 of our journey into 11.1 and 11.2, we're going to review some things that you guys talked about in geometry. Okay, this is trigonometry. It is a big part of algebra 2. It's an even larger part of pre-calculus. But what it does is it studies the relationships between the angles and the sides of triangles. Right? So we're going to just start with the ratios. So the way that you pronounce this, whether it's the full sign or like this, is fine. Okay? So don't tell me that that's sin. Or, well, cos you can say. But this is going to be the sine of theta. That is equal to the opposite side over the hypotenuse. Okay, the cosine is the adjacent over the hypotenuse. Okay, and the tangent is the opposite over the adjacent. This is one of my favorite math jokes. How we call it in at the beach. A tangent. Got that from a math book. Okay, so the SOHCAHTOA comes from the sine is the opposite, and then H is always the hypotenuse. Okay, the cosine is the adjacent, and then again the H is hypotenuse, so we can just abbreviate it there. And then your tangent is the opposite over the adjacent. Okay, now when you are using these trig functions, you are going to have a right triangle. So that means you will have a right angle in your triangle. Remember from geometry that right angles are going to have this box in the corner, and then you have this value of theta. Now in this diagram, your angle theta is here, but it could be at the top. So those are going to move from place to place. Okay, and then this just reviews for you the sine, the cosine, and the tangent. And then you guys can let me know. Have you ever heard of the cosecant, the secant, and the cotangent? Okay, so we are also going to learn about what are called the reciprocal functions. Okay, so remember, a reciprocal of a fraction is just a what? Not the opposite, the flip. Yep, because the opposite means, do you guys remember what opposite means? That's a common thing. Opposite is the signs, so positive to negative. Okay, and then the reciprocal is going to be the flip. Okay, so if it's cosecant, it's H over O for the cosecant. Okay, this would be H over A, because you just flip that. Okay, and then you have the cotangent. Okay, so you guys know SOHCAHTOA, and now you know Ho-ha-ayo. That's what I say. Just not as catchy though. I just say this part. Ho-ha-ayo. Okay, so a lot of times when people are getting used to the reciprocals, they flip-flop the cosecant and the secant because they're so close to each other. What I remember is if it starts with an S, the reciprocal starts with a C, and then vice versa. Starts with a C here, then it needs to be a S. Okay, so this is the reciprocal. This is the reciprocal. This is the reciprocal. Okay, so those do have a relationship, and we are going to be looking at that today. All right, let's make our geometry teachers proud here. What's the Pythagorean theorem? All right, a squared plus b squared equals c squared. Now the a and the b, it doesn't matter what you label the a and the b because the legs can go in any order, but the c is important because that has to be what part of the triangle? The hypotenuse. Okay, so we're going to draw a picture below representing the Pythagorean theorem. Okay, so you do have to have a right triangle. Okay, it doesn't matter if A is this leg, which we can call the short leg, this is the long leg. Okay, you can also put A here and B here, but C has to be the hypotenuse. Okay, now the hypotenuse is the longest leg. Do you guys know another way you can identify it if two of the legs look really similar? It's always going to be the one that's across from the 90-degree angle. Okay, so it doesn't matter which one is A and B because those are the legs. Okay, but C is across from the right angle. That is your hypotenuse. Alright, so in example 1, it says find the exact values. If a value is exact, it is not rounded. Okay, so you are going to be writing your exact values of the 6 trig functions for the angle theta. And then you do need to leave your fraction in the simplest form. So if we have to reduce, we are going to reduce. Okay, so our 6 trig functions include sine, cosine, and tangent, and then their reciprocals. Okay, so let's look and see where theta is located, up here in the upper corner. And then from here, I like to identify the opposite, the hypotenuse, and the adjacent side. So the hypotenuse is always across from the right angle. So we know that this is H right away. The opposite will never touch the angle. This is where you for guys. Okay, and then the adjacent will be part of the angle. So this is your adjacent side. Okay, so I always label those first, and then I'm ready to write out what my sine, my cosine, and my tangent are. So based on SOHCAHTOA, I want you to write out the sine of theta, the cosine of theta, and the tangent of theta. Make sure that you have the theta. If you're having trouble writing that, you can always just do a 0 and then put a line through it. Okay, but you can't have the sine of nothing. It always has to be of an angle. So we're using that variable theta. Alright, so Titan, what did you get for this sine?
6 over 10.
Good, so you got 6 over 10, that is your opposite over your hypotenuse, and then we're just going to go ahead and reduce it. So 2 goes into both, we'll reduce it to 3/5, okay, and then that is your sine of theta. And lock that in. Sine of theta is 3/5. Alright, and then Ryan, what did you get for your cosine of theta? Great. And then 2 goes into those as well. So 4/5 is going to be the cosine. Okay, and if you guys want to do the reducing in your head, you don't have to write it there. Just for your notes, I want you to have this so you can see it. Okay, and then Rocco, what did you get for the tangent? Yep. So 6 over 8 is going to reduce to 3/4. That's going to be your tangent. Okay, now when you go to the reciprocals, once you have the reduced ones, go ahead and flip your fraction. So we have 5/3 for the cosecant. Remember, sine and cosecant are the reciprocals. Okay, if you haven't already written down the secant and the cotangent, take a couple seconds now to do that. And if you already have and you want to start on the next one, that is fine. Okay, so Carson, what did you get for the secant?
5/4.
Yeah. And then Alyssa, what did you get for the cotangent? Yeah. Okay, so we're just taking those values and flipping them. chance to look at part B. So if you haven't already, will you please go in and label the opposite, the hypotenuse, and the adjacent side. And think about what we have to do for this one. So if you haven't yet, you're going to be labeling H, O, and A on your triangle. Okay, so show me what you get for your hypotenuse here. Sorry. Yeah, 3 root 10, good. Okay, so that's going to be your H, and then Will, what other side did you look for?
Opposite.
Good. And so this adjacent side is the only one left, but it's not labeled. Okay, so Kobe, what are you thinking? How can we find that?
You do Pythagorean theorem.
Yeah, just do the Pythagorean theorem. Okay, also, I forgot to mention that in your drawing you will have this here. Okay, so we just put in that right angle form here. Okay, so we don't know what this is for right now. I'm just going to call it B. And we're going to use the Pythagorean theorem. So we have 3 squared plus b squared equals 3 root 10 squared. Okay, go ahead and solve that for b, and then you can do your SOHCAHTOA. Okay, so you have squared roots before. Okay, so when you're squaring 3 root 10, you can think of it 2 ways. You can think of it as 3 root 10 times 3 root 10, or you can square the 3 and square the root. So 3 squared is what? 9, and then root 10 squared is 10. Root squared is what again? 9, okay. So 9 times 10 is going to be 90. Okay, so I do like to think of it like that. 9 plus b squared, subtract 9. And then this one is a perfect square. It won't always be a perfect square. Okay, but your value for b is going to be 9. Okay, so b equals 9. That is our value. Okay, now when you are writing out your sine, your cosine, your tangent, you are going to have to write this out in its simplest form. So the sine of theta is the opposite 3 over the hypotenuse 3 root 10. You can simplify 3 divided by 3. Okay, but remember, when you're simplifying, you also have to rationalize the denominator. So we are going to multiply this by root 10 over root 10. Okay, so 1 times root 10 is root 10. Root 10 times root 10 is 10. That's going to equal the sine of theta. Okay, that is your answer in simplest form. Now, what I'm going to recommend that you do is after you find the sine for this one, let's go ahead and do the reciprocal. So the reciprocal of sine is the cosecant. Now, I can flip this root 10 over 10, that is fine. And then I have to simplify again, okay? I'm going to show you what that looks like. You don't have to write that down, you just have to pay attention. Okay, so if I were to flip this, then I would have to rationalize, so I'd have to multiply by root 10 over root 10. I have 10 root 10 over 10, right? So then what would happen here?
Root 10 over 1.
So just root 10 would be your final answer, okay? So what I'm going to suggest, instead of taking the simplified answer, before you rationalize, do you see how you have 1 over root 10 here? Okay, what you can do is you can just flip that. So if you do the reciprocal, it's root 10 over 1. And that's just going to simplify root 10. Okay, so it's a little less work to do it that way. Okay, if you forget and you simplify the other way, fine. Okay, but that's just something else that you can use. Alright, so based on what we just heard the sine, I want you to go ahead and give the cosine a try with the secant as well. Okay, so we'll use this time to practice. Start thinking about, hey, do I know how to set this up? Okay, and then I'll look around, so if you're having some trouble, I can help.
Chemistry over. Kevin over.
No.
Reaction.
Alright, so for your cosine, when you have 9 over 3 root 10, you can simplify. Okay, 9 divided by 3 is 3, so it becomes 3 over root 10. So you have 3 root 10 over 10 is equal to the cosine. Okay, when you are doing the reciprocal, feel free to go back to this step here. So the secant is going to be root 10 over 3. And then for your tangent, this one's pretty nice. You're going to get 3 over 9, which reduces to 1/3. Okay, and then if you flip that, 3 over 1 is just what? 3. So that is what you are going to write. Don't leave it as 3 over 1. You want to leave it in the simplest form. Alright, then in example 2, it tells you in a right triangle, angles A and B are acute. That means angle C is going to be the right angle. you're finding the exact values of the 5 remaining trig functions. Okay, so they are going to give you one of them. The cosine of A is 3 over 10. Feel free to draw a picture. Okay, as long as A is one of the acute angles and B is the other acute angle, you are fine. So you can call it A, B, C, or you could switch those two, doesn't matter. Okay, so now I'm going to set up the cosines for A. So cosine is the adjacent over the hypotenuse. So I'm going to have 3 over 10. Okay, so we're going to solve to find our missing side. Okay, and I'm going to call this missing side A just because it's across from angle A. So 3 squared plus A squared equals 10 squared. Okay, we know that that's 100. This is 9. So if we subtract, we get -1. Okay, now because this is the side length of a triangle, we don't have to worry about putting the plus or minus. The side length is going to be a positive value. Okay, root 91 is not a perfect square. Okay, there aren't any perfect squares that go into it, so we're going to leave it as root 91. Okay, so based on that, go ahead and find your sine, your cosine, your tangent, and the reciprocals. Okay, so I'll give you a moment to get some of those down. And when you finish that, if you want to start thinking about part B, you can draw your triangle. So when you're doing your sine, you already have your cosine. When you're doing your sine, your tangent, the reciprocal, instead of theta this time, it is of A. So make sure you have the sine of A, cosine of A. Okay, so I'm going to get for the sine of A here. So remember the sine's the opposite over the hypotenuse. Okay, so I think you said a couple of times you need to find the sine of A, right? And just get the measure. So let's do it together. So the sine of A is opposite. So what's your opposite side? So from A, what's your opposite? Close. Root 91, right? Okay, so this is your opposite side. What is your hypotenuse? Alright, now, if the square root is in the numerator, okay, then you don't have to simplify. Okay, when you go to find the cosecant, which is the reciprocal, you have 10 over root 91. That's when you have to simplify. Okay, and then you don't have to find the cosine, that's given. So if the cosine is given, you just have to flip it. So the secant of A is just 10/3. Okay, and then do we need another minute to do the tangent and the cotangent? Okay, and then if you're done, go ahead and set up part B. That one is a little bit trickier. So why don't you label your triangle, put in any variables, and then I'll give you a hint. You have to write 2 as a fraction. How can you write 2 as a fraction? As a ratio. Alright, and then Alexa, what did you get for your tangent for part A?
Three times root 91 over 91.
So the numerator is going to be your opposite side. So if this is A, the opposite is going to be which side? From this angle. Okay, so the opposite side from A, so if this is your angle, which one of these 3 sides is the opposite? 10 root 91 or 3? Yes. Okay, and then which one is the adjacent? Yep, because 10 is going to be the hypotenuse. So this is going to be what we have for the tangent. Now the cotangent, that's the one where you're going to be multiplying, which I think is what you were saying, because that's what you have in your work, right? When you multiplied it by the root 91 over the root 91. So you have 3 root 91 over 91. And that is for the cotangent. Alright, and then for B, I did give you guys a couple hints. If you haven't had a chance to draw a picture yet, let's go ahead and do that. So it is a right triangle. Okay, and then I just called this one B. This was C and this was A like last time. Okay, so when I did this for angle B, I thought of 2 as 2 over 1. That's your opposite over the adjacent. So the opposite side would be 2. The adjacent would be 1. And then I just have to use the Pythagorean theorem to find that third side. Okay, so 2 squared plus 1 squared is going to be 5. Okay, so then when you are trying to find C, you're going to square root both sides. Take the positive value since it is a side length. And then this time when we're writing out our final answers, we are going to use B. Okay, so the sign of B. Okay, and you might want to find the cotangent first, because you can't do that for result. The cotangent of B, you just flip this. 2 over 1 is 1 over 2. once you get your fractions, just check to make sure, or once you get your ratios, just check to make sure they're simplified. All right, and then here, let's talk what you got for your sign of good. This should be your final answer. So when you are setting this up, you're always asking yourself opposite over adjacent, and then we multiply. Okay? So when you're finding your cosecant, you have root 5 over 2. Okay, do you have any questions for me at this point about finding your reciprocal functions? Okay, and then your cosine is root 5 over 5. And then your secant, again, I just recommend that you flip this. And then you won't have to do any extra simplifying. Alright, so it looks like we do have some good knowledge about how to use SOHCAHTOA Pythagorean theorem. We are going to apply that to the next one. I noticed some of you are working ahead and then we stop when we got here. So, it says P is a point of the terminal side of theta in standard position. You're finding the exact value of the 6 trig functions for theta. So your point P, let's just graph that. This is a point, right? So everything we're doing with SOHCAHTOA is based on triangles. So we're going to be making a triangle. Okay? Let's just go by threes. Is that fine? Okay, so I need a positive 9 on the y. I'll even go for a row of threes here. Alright, so I want you to plot that point. Over -6 of 9. It says that's the terminal side. Remember, when we were doing the terminal sides, that was just our ray with the vertex at the origin. Remember the terminal side that we talked about the other day? Okay, in this case, we use this to create a triangle. So, we know the length, oh, so close. We know the length from 0 to y is going to be 9. Okay, the distance here to here is -6. So those are going to be the two sides. And then your theta value is going to be here. Okay, this is your theta value for the triangle. Okay, so it's your theta value for the triangle, not for like the angle in standard position there. Alright, so with this triangle, we just have to find out what the hypotenuse is. Right? This is -6, this is 9, this is our theta. So we're going to use the Pythagorean theorem. Okay, to find C. Okay, so when you're adding these, 1 and 6 is 7, 8 and 3 is 11. Okay, and then we need to see if any perfect squares go into 117. So remember, one strategy we have for that is the factor tree. 2 doesn't go in there. Does 3 go in there? Yeah. The adjacent side for this, the distance isn't negative. It's not your side length is 6, but we are going to use the negatives once we put them on the grid. So I'll talk about that a little bit more in a minute. So let's finish our factoring. So with dividing by 3, how many times does 3 go into 11? 3 times, with how many left over? If you need to, if you're more visual, like it's hard for you to do some of that in your head, you can just write it out, right? How many times does 3 go into 27? 9 times, so 3 times 39. Okay, does 3 go into 39? Yeah, how many times? 13, and then remember the rule. If it's a square root, if there's a group of 2, the 3 comes out, the root 13 is stuck inside, okay? Okay, now, we are going to use these to find the values of sine, cosine, tangent, and their reciprocals. In this case, P is a point in the standard position. So once you are dealing with points on the grid, you are going to be working with positives and negatives. So earlier, we were given triangles. In the triangles, you are going to have positive side lengths. This is a point, and we are constructing the triangle from that so we can use the Pythagorean theorem, but you do have to make sure you keep this a negative when you are calculating your ratios now. So for the value of sine, again, I like to write, this is my hypotenuse, this is my adjacent, this is my opposite, so I can do the SOHCAHTOA. So for my sine value, 9 over 3 root 13. Okay, go ahead and simplify. So you are going to have some negative values now when you are working with your points. Okay, those points are going to correspond to places on the coordinate grid. All right, and then no, what did you simplify the sine of theta to? Correct. 3 root 13 over 13. If you're having trouble getting there, this is your first step, and then you're going to multiply. Okay, like you said, I like to do the reciprocal next. So I take this first step here, 3 root 13 over 9, and then I simplify. So now this simplifies to 1 over 3. So the cosecant is root 13 over 3. Alright, and then when you set up your cosine, you're doing the adjacent, so negative 6 over the hypotenuse. Okay, and then Carol, can you tell me how you simplified that? And then what you got for the cosine? Good. Yes. Alright, and then what do you have for your sine? And then from there, we can do the secant. Okay, so if you have this negative 2 over root 13, you can just flip it from there is fine. Okay, or you can reduce again. Alright, and then you'll know what to get for your tangents. Yeah, so you have 9 over negative 6, and that's going to reduce to negative 2 over 2. And now we just do the flip.